Hello everyone. In this video, we will be discussing about what are the factors to be considered while designing machine parts to avoid fatigue failure. So when we speak about fatigue failure, we should be knowing and even what causes this fatigue failure. As we discussed in the previous different types of loads, we had a concept called yield stress or the yield point or the ultimate stress or ultimate point. So when a metal body, a load is applied on a metal body, in case if it is crossing that particular yield point or the ultimate point means we call that particular body as a failure, failure metal. Since it is losing its contour over the yield point and the ultimate point. But fatigue is something before reaching its yield point or ultimate point, it will go under failure because of the repeated or the continuous loads. So even though some applications we cannot completely avoid the fatigue failures, for example, if you take shaft or if you take fan or if you take some examples where the repeated work only will be keep on continued. Such situations and all we cannot avoid any kind of we cannot avoid the fatigue failure, but there are chances we can reduce the intensity of the fatigue. So in this video we will be discussing about the factors what and all to be considered while designing machine parts to avoid fatigue failure. Avoiding, practically it is not possible for all the machine parts, but as much as possible it is possible. We'll see one by one. The first point is the variation in the size of the component should be as gradual as possible. It means the size of the component, when I speak about means the cross section, as much as possible the uniform cross section from one end to another end uh, is should be avoided, because that makes like a uniform load distribution. So ultimately fatigue failure will be there. So to avoid that, if we do the variation in the cross section, then the fatigue failure can be avoided. Next is the holes, notches and other stress raisers should be avoided. So indirectly telling that stress concentration factor, all the stress risers should be avoided. The proper stress deconcentrators such as fillets and notches should be provided wherever is necessary. And yes, we need to make sure that there is no any sharp corners or edges, and proper like a fillet smooth surfacing was done. We need to confirm it to avoid the fatigue failure. Then the parts should be protected from corrosive atmosphere. So when we choose the material, we need to make sure that where it is taken for the working. So the working environment, we need to make sure that uh, even though it is allowed in the normal corrosive atmosphere, the material should not go under any kind of corrosion. And the second thing, next one is a smooth finish of outer surface of the component increases the fatigue life. This just now I explained this. Then the material with high fatigue strength should be selected. The residual compressive stresses over the part surfaces increases its fatigue strength. Now we have another interesting topic, that is endurance limit and fatigue failure. So it has been found experimentally that when a material is subjected to repeated stresses, it fails at stresses below the yield point stresses. Such a type of failure of material only we call it as a fatigue. So the failure is caused by means of a progressive crack formation, which are usually fine and of microscopic size. It means the crack is not visible. Only through microscope we could able to view the crack. And the failure may occur even without any prior indication. Suddenly, as of the sudden, this crack may appear. The fatigue of a material is affected by the size of the component, relative magnitude of static and fluctuating loads, and the number of loads reversals. And here you can able to see a standard mirror polished specimen in this sketch, where it is rotated in a fatigue testing machine while the specimen is loaded in bending. You can able to see this is a specimen which is having these kind of shape, and the dimensions is given, and which is fixed in a fatigue testing machine, and even a certain load is fixed in the center of the specimen, so that it will even tends to bending. As the specimen rotates, the bending stress at the upper fibers varies from maximum compressive to the maximum tensile stress, while the bending stress at the lower fibers varies from maximum tensile to maximum compressive. Even we can call it as vice versa. In, like in simple words, if you want to understand means, Initially, the upper part will be compressive, lower part will be tensile. If within a half rotation, the compressive becomes tensile and the tensile becomes compressive. So the specimen is subject to a completely reverse stress cycle. So this is represented by time stress diagram. You can able to see in this sketch where there will not be any mean stress because the fluctuations, the amplitude fluctuations, you can able to see the upper amplitude, lower amplitude, any cycle if you take means it becomes same. So that is why we call it as the amplitude stress. The stress amplitude is very equal in all the the cycle amplitudes. So, endurance of the fatigue limit is defined as maximum value of the completely reversed bending stress which a polished standard specimen can withstand without failure or infinite number of cycles. Usually, 10 power 7 cycles is recommended. It may be noted that the term endurance limit is used for reverse bending only, while for other types of loading, the term endurance strength may be used when referring the fatigue strength of the material. It may be defined as a safe maximum stress which can be applied to the machine part working under actual conditions. We have seen that when a machine member is subjected to a completely reverse stress, the maximum stress in tension is equal to the maximum stress in compression. And even it was shown in the sketch 1. In actual practice, many machine members undergo different range of stress than the completely reverse stress. The stress versus time diagram for fluctuating stresses having values from the minimum stress and the maximum stress is shown in the third sketch. The variable stress in general may be considered as a combination of steady or even we will call it as a mean or average stress and a completely reversed stress component sigma v. You can able to see a fluctuating stress cycle where the fluctuation, the amplitude will be having the positive quadrant that to above some value. So that is why here we have the maximum stress value and the minimum stress value and amplitude stress value we can able to see this. So the alternating stresses where the amplitude stress formula is sigma max minus sigma minimum by 2 and the mean stress is sigma max plus sigma minimum by 2. Then we have next topic that is factors affecting endurance limit. So we have many factors, size factor that is size effect, uh, surface roughness, effect of temperature, and effect of metallurgical variable. So all those things are there. So before moving to these things, we should have a detailed information about all these things. So what is this modification factors? Let me take this particular example. Yeah, let me take this particular example. Assume that this particular component is going under fatigue testing. That means that it is going under the reverse stress cycle. So what is this modification factor? I'll be considering three modification factors based on the size of the specimen, based on the surface of the specimen, and based on the load which is applied on this particular specimen. Example, if I speak about the load, so the load means it can be axial load, it can be a bending load, or it can be torsion. So based on the different types of load, the modification factor, we are denoting it as either EL or KL. And similarly, moving to the next one, we have size. So based on the diameter of the specimen, maybe starting from diameter 0 to 8 mm or 8 to 50 mm or 50 to 100 mm like that. So based on that, we will be fixing up the modification factor for the size. And even we have for the surface, it can be a rough surface, it can be polished surface, or it can be semi-polished surface. So based on all these parameters, we will be discussing this modification factors. Moreover, this modification factor concept is very much required while solving the fatigue problem since stress concentration plays a vital role in the fatigue problems. We'll discuss in detail about all these modification factors in the upcoming video. Thank you.